G'day everyone and welcome back to the trigonometry series for 5.3 mathematics. In this video we are going to focus on the sine rule. So we can see here in the little blurb that we can use sine, cosine and tangent functions with right angled triangles, but we can also extend it out to non-right angled triangles. Okay, so over to the right hand side of the screen, we have a triangle with corners of A, B, C, and then sides A, B, and C, and the height there is H as shown. Now, one thing to know is that angle B is opposite side B, and so for around the triangle, angle A is opposite side A, angle C is opposite side C. Now let's fill in some blanks here from the triangle CPB. So let's highlight CPB. So CPB is this one. Okay. We can say that H over A equals sine of B. Okay, we have the right angled triangle in there. H over A, so opposite over hypotenuse, is the sine of B. So H is A sine B. From the triangle CPA, which is this one, we can say that H over B is equal to sine A. So H will also equal B sine A. Now this is going to make more sense once we get into the examples and you can see it in a little bit more action. That one in there, don't. Sometimes I have these extra bits. Don't worry about that. Now, therefore, A sine B is equal to B sine A. And another way we can actually write that is A over sine A is the same as B over sine B. Okay, and it can extend out to the side of C being over sine C, if I get that letter right. There we go, much better. Let's keep moving through. We're going to start to look and see where some of these are happening. Okay, now it is important when labeling your triangle that the capital letters for vertices, so the corners of your triangle, so the corners or vertices of the triangle get the uppercase letters or the capital letters, or block letters as some people might like to call them. Okay, and then the sides opposite each vertex or corner get a lowercase or little letter version of the letter. And you can see here in our example that the A side is directly opposite the uppercase A, B is directly opposite uppercase B, and C is directly uppercase C. Okay. Now the sine rule itself is essentially what we've written at the top of the screen there. And we're just going to write it again. It is A over sine A equals B over sine B equals C over sine C. Now we usually only ever use two of those because it just makes it easier to only have the one equals sign. But what it states is that the ratios of each side of the triangle to the sine of the opposite side are equal. Or opposite angle, sorry. Okay, that's what it's doing, and this will be true for both acute angle triangles and obtuse angled triangles. Okay, so this will happen no matter what. Works for all of them. When is this happening to be useful? Well, it's very useful to find things out when you only have the sides of one angle. So if you've only got the sides of one angle, the length of the opposite side to that angle and the length of another side. Okay, so that's when it's pretty darn useful. Now, you can see there we have what we call an ambiguous case. Now, this tends to be when you have two sides in an angle that is not actually included. Let's write that in. So this may happen when we have two sides and an angle that is not included. Alright, so we've got a bit of an example there. We're given two side lengths and the one angle. Okay, two different triangles contain the information, and we've been given some other stuff. So in the example, two given side lengths, so we're given the 10 centimeter side length and the 6 centimeter side length, and we're also given the angle of 30 degrees. Okay, we can create the extra triangle, okay, with 6 centimeters, and you can see there that it's just moved that line around, so it's kept it at 6 centimeters, and that's going to give us two potential results for theta. So if we use our sine rule, okay, so if we remember our sine rule, we've got A over sine A equals B over sine B And we can fill in some gaps now. So if we use the 6 over sine 30, okay, and that's going to be the same as 10 over sine theta. Now what's going to happen here what's going to happen here is that you could get two results for theta. Alright, so there's a theta 1 and a theta 2. Alright. Two valid results. One could be an acute angle, one could be obtuse. The obtuse angle being the supplement of the acute angle, but sometimes that obtuse angle is not the valid solution. So we'll just make a note of that one. Sometimes the obtuse result is not valid, and we're likely to see that at some point in your questions. Let's now have a look at some examples. Find the value of x in this triangle correct to 1 decimal place. So let's start with our rule. And then I'm going to give it some labels over here. So I'm going to label this as A, B, and then that's going to be A and B. Fill in what I know. So it's going to become x over sine of 80 equals 7 over sine 75. We should probably put our degree signs in. Now, following some basic, both sides by sine 80. And that's going to get us x equals 7 sine 75 multiplied by sine 80. That will actually get us to 7.1368 ... which to 1 decimal place will just be 7.1, and that'll be in meters. So it's just knowing how to use our formula, how to apply our formula appropriately to the diagram we have, and then just following our basic skills for solving equations. Now we can go the other way. So that one was finding the value of the side. We can actually find the value of the angles as well, just by flipping those around. So we're actually going to use sine of A over A, sine of B over B. Right? Still works. Okay, so let's see it happen. We have over here, we're going to go sine of A over A equals sine of B over B. I am going to make this A, and that makes that B, and this B. So what's going to happen is I'm going to have sine theta over 9 equals sine of 83 over 10. Do our algebra, so multiply everything by 9. Okay, and we're going to have sine of theta equals 9 sine 83 all over 10 because we're multiplying. So 9 is the numerator, so it just gets multiplied across the numerator. Okay, and then remembering that we are using our inverse. So theta is sine to the -1, 9 sine 83 over 10. Now that should be 63.289 ... because it keeps going. We want one decimal place, so it's just going to be 63.3. Okay, 63.3 degrees. Let's have a look at the next one. I'm going to finish off with this last one. Start in the same place. So sine of A over A equals the sine of B over B. Let's label some corners, so I'm going to make that A and A, B and B. You can use C if you really wanted to, doesn't really affect it. This is just the easiest way to do it. So we're going to have sine of theta over 6 equals sine of 40 over, that should have been a 4. Okay, same idea, we're going to multiply everything by 6. That's the numerator, so it just gets spread out across the numerator. So sine theta equals 6 sine 40 all over 4. Theta will be the inverse of sine 6 sine 40 all over 4. Type that into your calculator and we should actually get 2 potential responses. Now for this one, we definitely want an obtuse angle. Okay, so when we work this out, it should come out to 74.6 degrees. There will probably be a few more decimal places to that. But we want to find its supplement. So remember when we spoke about the ambiguous case and it being a supplement. So that means it's 180 minus 74.6, which is 105.4. Okay, and it's an obtuse angle. Therefore, theta can't equal 74.6 because that's acute. It has to equal the 105.4 degrees. Okay, remembering this is a supplement. Now, that's going to be a little bit tricky while you're doing your classwork and doing your questions. Good luck with those though. See you in the next video.